Hello students, today we are going to discuss about dynamometer electromagnetic moving coil instrument. A dynamometer type measuring instrument are similar to PMMC instrument. In this session, we are going to discuss about what is dynamometer, what is its constructions and working principle, what are the errors induced in it, and what is the advantages and disadvantages of dynamometer instrument. Then we'll first going to discuss about what is dynamometer. Dynamometer type measuring instruments are similar to PMMC instruments, except the permanent magnetic field coil is replaced by a coil which carries the current to be measured. In the case of dynamometer, the permanent magnetic field coil is replaced by a coil which carries the current to be measured. They have precision grade and accuracy for both for AC and DC measurements. Dynamometer measures are utilized for both AC and DC measurements. Then we are going to discuss about what are the construction of a dynamometer instruments or electromagnetic moving coil instrument. A fixed coil is divided into two equal halves. The moving coil is placed between the two halves of the fixed coil. Both the fixed and moving coils are air-cooled so that the hysteresis effect will be zero. The pointer is attached with the spindle in a non-metallic former. The load moving coil is wounded. It is the controlling method in this system is spring control method, and the damping air friction damping is used in this type of instruments. This diagram shows the construction diagram of a dynamometer. Then we are going to discuss about its working principle. When the current flows through the fixed coil, this is fixed coil. When the current flows through the fixed coil, it produces a magnetic field whose flux density is proportional to the current through the fixed coil. The moving coil is kept in between the fixed coil. This is one fixed coil, this is another fixed coil. Here the moving coil is placed. Moving coil is placed between the fixed coils. When the current passes through the moving coil, a magnetic field is produced by the coil. Then the magnetic poles are produced in such a way that the torque produced on the moving coil deflects the pointer over the calibrated scale. When the current passes through the moving coil, a magnetic field is produced by the coil. The magnetic poles are produced in such a way that the torque is produced on the moving coil deflects the pointer over a calibrated scale. This instrument works on DC and AC. When AC voltage is applied, alternating current flows through the fixed coil and moving coil. When the current in the fixed coil reverses, the current in the moving coil also serves as a quantity. The torque remains in the same direction since the current I1 and I2 reverse simultaneously. This is because the fixed and moving coils are either connected in series or parallel. This is all about the working principle of dynamometer. Then what are the errors? Errors in dynamometer. Then the first error is frictional error. Since the coils are cold, therefore the magnetic field produced is of small strength. So they require a large number of ampere turns to create necessary deflecting torques. That's why this results in the heavy moving of instrument. Therefore, a small torque weight ratio, thus the frictional loss in dynamo type instruments are somehow larger as compared to other instruments. Then the error is temperature error. Since the operation of dynamo type instrument required considerably power, self-heating in these instruments is appreciable. The error due to self-heating may be much as 1% of the full scale deflection. Next, error due to stray magnetic field. Since the operating magnetic field produced by the fixed coil in these instruments is somewhat weaker in comparison to that in the instrument of the other type. The operation of these instruments is more sensitive to the stray magnetic field. Frequency error. The change in frequency causes two types of error. Causes due to two reasons: due to change in reactance of operating coil or due to change in the magnitude of eddy current set up in the metal part of the instrument near to the operating portion. Then going to the next part of this lecture, that is the advantages and disadvantages of dynamometer type instrument. First, we will discuss what are the advantages of these instruments. These instruments has square law response, so can be used for both DC as well as AC. These instruments are free from hysteresis and eddy current errors. Ammeters up to 10 ampere and voltmeter up to 600 volt can be constructed with the precision grade accuracy. Dynamo type voltmeter are useful for accurate measurement of RMS value of the voltage irrespective of a waveform. Because of the precision grade accuracy and same calibration for DC and AC measurements, instruments are used as a transfer and calibration instruments. Then what are the disadvantages of this type of instrument? The scale is not uniform as the instrument use square law response. These instruments have small torque weight ratio, so the friction error is considerable. Owing to having heavy moving system, friction losses in these instruments are somewhat more than those in other instruments. As a result of measures taken to reduce the frictional errors, their cost is more in comparison to moving iron and PMMC instruments. They are more sensitive to overload and mechanical impact and are to be handled with care. Adequate screening of the movement against the stray magnetic field is essential. The sensitivity of the instrument is typically very low due to poor deflecting torque. The power consumption of this instrument is comparatively high because of their construction. This is all about a dynamometer type of instrument.